So I'm in the technical marketing group, and I get the fun of playing with all these toys. All right, I got a couple of racks in that server room, a couple of UCS chassis, handful of rack-mounted blades, probably about 200 ports of 10 and 1 gig network infrastructure, and right now I think 6 Nimble arrays.
But you have all the good toys.
So some of those arrays are in what I'll call demo production. All right.
Don't let Howard get in there. You might have 5 Nimble arrays or 4.
Well,
3.
Yeah. they're a little heavy to carry. So when I install one, I usually get a second per hand. But about 6 arrays right now in various configurations of what I call a demo production, meaning we don't mess with them. We use them to stand up applications and do our field demos and whatnot. A couple of them in test mode, and we'll be playing with those today. And then we have a few of the beta ones as well. So I get to work sort of on both sides of what engineering is building and our customers are working with. And one of the things I want to point out is that, and we're going to see this hopefully here in the next 15 to 20 minutes, the simplicity of the Nimble array lets me do a lot of things like worry about the application space and the networking infrastructure. And I brought a few of my friends just outside the room there, sitting on the chairs. There's some hardware there that we're going to actually go through and do a live upgrade. I'm going to walk through a few things here, and then I'm going to turn over the control so you can continue getting some education. And I'm going to spend about 15 or 20 minutes and completely upgrade one of our systems from last month's model to this month's model. Is one way to look at it, okay? So for a quick demo, though, I don't know how many of you have actually had a chance to get hands-on with a Nimble, look at the UI. I'm just going to spend a few minutes just going through the high-level management aspect of it. All right, we're going to provision a little bit of storage, look at a couple of sneak peeks about how we manage snapshots and replications. I'm not going to delve into a lot of detail here because you're probably not storage admins, and I really want to get to the last bullet on this slide, which is turnover control, and then go have some fun in the lab. So let's jump to, so I have 2 systems now running in the lab, and this one is the one that we're going to upgrade. So I'm going to mark this one to the left and call it the before, all right, when we get to the point here. This is a CS260 array. This is the management screen. And is that in focus enough? Yeah. Okay. And what we can see here on the management screen at a very high level, I'm not putting a lot on this system right now. All right, this is one that I basically stood up yesterday to do the little dog and pony back there. But I also have a system here that's a little bit further along in its life and has a little bit more storage on it and a little bit more things working in it. So we're going to be looking at these two. Both of these systems right now are actually in a replication context with each other. And I can see that is if I go to, for example, manage my replication partners, I can see that this array is pointing to TFD demo, which is in the other screen, and this array is pointing to my marketing CS240G, which is actually going to have to get renamed because he recently went through an upgrade. So he's actually a 440G now. And he'll be a 440GX2 probably sometime next week. So this is just a real simple, just to show that these 2 arrays, these 2 screens, are in replication with each other. This one here has just a couple of volumes on it that we're going to play with today. And the other array, just to kind of give you an idea, has a little bit more going on it. And this one supports a lot of our in-house testing for VDI, for ESRP, for VMware SRM, a number of things. So we basically have a number of volumes. Some of these are turned off and turned on depending on what we're running today or not running today. So we can see at the high level here, if I go to the home page again just real quick, we get a quick overview status of how much storage is actually used. And I heard some people talking at the outset about trying to hide this pie chart a little bit from the real users. But we are thin provisioning and compressing, and we get a feel for how much is actually being used down here. A status of the system, this one's very clean. You'll notice that the other one's been through a couple of controller restarts, and that's in preparation for today's activities. So we get a high-level view here. And also, an idea of what's been running on this. So now I've been running some basically simple workload just to keep the array busy, to keep some stats collecting for our analytics department. And hang on a second. This is on already. Right. I had a microphone in my pocket, and I'm like, did I turn that on? So we can see that this one's.
In your pocket or just by the seat?
Yeah. So this one's running somewhere north of 50,000 IOPS. It's just a steady state workload that we're running to kind of keep some statistics gathering, even when we're doing stuff like this. All right. I'm going to flip back over here for just a
Joys
second.
of being so lightly utilized, it's all going to flash.
Well, the thing is what I want to make sure is that I've got a volume access large enough so that it is actually working flash, memory, network, and the client side. And so what I want to do is make sure that at the sort of peak edges of the workload, I don't have any problems. All right, it's real easy to have something demoing at a couple of hundred or 1,000 IOPS and not see things in the corners. So this other array that we're going to actually upgrade a little bit later is running about 20 or 30,000 IOPS lower. All right, we're going to solve that problem. All right. So real quick, I wanted to show the simplicity of management here. So to provision a volume on the Nimble array, it's a very simple task. I go into Manage Volumes, and I click on New Volumes. Now, I probably need to get a little bit of information from whoever wants this storage. All right. I'm free to name it what I want here, and that's usually one of the hardest things, but I'm going to call this one Demo, because that's an easy one to remember. The performance policy here is a very interesting thing. All right. This is a property of this particular volume I'm going to carve out. So I'm carving out an iSCSI LUN, and I can assign a performance policy. Think of it as an attribute or a property. And we have some predefined here. And what these do is they give us a hint as to what you might be doing with that volume. All right? I can define my own performance policies. All right? And these performance policies as properties will come up in some of the analytics that we'll do later. All right? So I can always pick default. That's kind of like throwing everything in lowest common denominator, and things will work fine. But the performance policy lets me set essentially a block size I/O characteristic, but also compression and caching. All right? And Umesh talked briefly about some of the things that happen at the causal layer. I might know, for example, that this volume is going to just take a sequential load. All right? And I'll turn off some of the caching. All right? I may want to have a volume for pre-compressed data, so I'll turn off compression. I don't have to, but I can get small amounts of improvement by giving Nimble a little bit of hint as to what's going on. More, yeah, go ahead.
Oh, sorry. I was just wondering if you could show us at some point in the demo the new performance policy screen. I'm curious what kind of dials you can do.
No, I was going to say, we can click one here, and I can basically say, here's a demo policy. All right, and some things that I can manage in here, like I said, is block size, compression, caching, and then we reserved this for some more advanced work that I'm going to let sort of come out in the discussion that we do on our analytics. But like I said, it's very simple here. More importantly, the name here is going to allow us to track some of this information later as we pull the data off of the systems. All right?
I just want to interject
Sure.
here that the data layout that I was talking about, the log structured layout, which gives us variable block size, is what enables us to optimize the block size based on the application. So rather than always having to work with a common denominator of 4 kilobyte, Exchange 2010 uses a 32 kilobyte block size. So by going up to that same block size, we reduce the amount of metadata we keep internally. So things are both, things are efficient in both space and time.
Thanks. So the performance policy basically lets us tune a little bit of the behavior and also track some characteristics. And there's a number of ways that this could be also used. Provisioning storage fairly simple. I'm going to limit access to this particular iSCSI LUN to, guess what, the demo host. All right? And I scroll down here a little bit, click Next, and I can create a size here, and I'll just do a 500 gig. This is going to be thin provisioned. Some other things that I can set here, the defaults are typically perfect, and it kind of depends on how you want us to manage and reserve storage. But I usually just leave these go for now unless I have another reason. And scroll down, click Next. And then I have to make a decision here about how I want to protect this particular piece of storage. All right. I can choose to leave it unprotected, which means it's just going to be an iSCSI line on this array and no snapshots or replication going on. Or I could choose to drop it into a predefined or existing volume collection and protection policy that defines what's going to happen. So if I drop this volume now into this replication demo, and you see I'm fairly creative in my names here, this will snapshot every 20 minutes, every hour of the day, every day of the week, and it's going to replicate over to that other array that I showed you. All right? So I'm just going to, for safekeeping, because I tend to have backup copies of a lot of stuff, I'm going to say go ahead and drop that into that particular, yeah. We're going to get a replication sync here in just a minute.
Can't have too many copies.
Okay? So back to managing volumes. Now I have my new volume here called demo. And we can see that there's basically nothing here. I'll present this to the host, go ahead and use it however I want. At this point, that volume now appears on the iSCSI network to my user. All right? All right, a couple of other things I wanted to point out here. So in these volume collections, and let's go to the thing that I dropped it into, which was my replication demo here. We can see that I've already got snapshots running here, and I'm keeping about 10 on this system, and I'm keeping about 5 on the other one. So if I go back and I want to look at the definition of this particular policy, is I'm not doing any synchronization. We do have integration with host layer and basically guest layer type synchronization. The schedule here defines what's going to happen with that particular volume, and then the volumes that are in that protection or in that volume collection. So it becomes very easy to organize and provision storage, all right? And then the last thing that I typically do, and particularly in what I work in here, is I like to see what's going on. And so I can go and monitor a number of things about my environment. So on this particular array, I can go monitor the performance sort of in the last 5 minutes, in the last 60 minutes, or even in the last day. If I want to look at things that are going on in my environment. I'm going to leave this up for the last 60 minutes because this has been running in the lab since the meeting here started. But I can also monitor other things like the interfaces on the array, the replication with my downstream or upstream partners, connections to my hosts, a number of things very simple here. So I can literally provision the storage. I need a name, a size, some hints about how I'm going to organize it, and then how I'm going to protect it. All right? And then I go about and do my other work. All right? I don't have to worry about RAID groups. I don't have to worry about disk shelves and layouts and a number of things. So I'm going to segue for just a minute now back to what I wanted to cover here. All right? And walk through very quickly what's going to happen when I leave the room. All right, so we've looked at the home page. I'm going to set my laptop over on a chair over here with the performance monitor running in the system page while we get onto some of the other discussions. But the thing that I'm going to look at here is this scale to fit, and we're going to do essentially a live upgrade here and come back at the end and look at the results. And what that involves, and actually, I think I brought the screwdriver. If not, it's on my chair. That's really the only tool I'm going to need. All right? So controller upgrades. All right? Systems running live in the lab. All right? Services keep running. All right? What I'm going to basically do, and the screwdriver is needed here because my chassis is bolted to the front of the rack so it doesn't fall out should an earthquake hit. Right? So there are, and I tend to tighten them a little tighter than I can untighten them, so I carry a screwdriver. All right? I'm expecting when this whole process is done that without changing the disks, without changing the host, the network, or anything, all right, I'm going to take out my 200 series controllers and put 400 series controllers in. It's going to take a few minutes to kind of get things back and forth. My system performance should jump up almost 2x, maybe more. All right, and again, what's going to happen then is I might have to go do a little bit of tuning about networking and whatnot. But that 30-some thousand IOPS that's running on this system, I expect to actually get above the other one because the other system is running a virtualized environment, and that's a VM producing that workload of close to 60,000 IOPS. Same test workload, two different, slightly different host environments. All right? And the way that I'm going to do this is I'm basically going to halt the standby controller and replace it. And then I'm going to fail over to the new controller, and I'll be halfway there. All right? Then I'll have a new standby controller on the other side of the array. I'm going to let that stabilize, halt it, and replace it with the new hardware. And then I'm going to do one last fail back, and I should now have essentially a new 400 series, 400 class array without changing any of the rest of the infrastructure. And it kind of is going to be about that simple. I mean, I brought the screwdriver because the back plate actually has a little security screw on it as well to keep them from vibrating out. So there's a screw on the front to hold it to the rack and a screw on the back to hold the controller and the chassis. That's about all I have to worry about today. All right? Once this is done, I should be able to basically go about doing something else, and my array will run about twice what it was doing. All right? I'm going to do that, pop back in, check on the screen. I'll interrupt Larry or Suresh or whoever's presenting for just a moment just to kind of let you know, and grab some more parts off the chair. And then I'm going to do a non-disruptive flash upgrade. All right? This is fairly simple too. All right? Services keep running. Users don't know I'm doing this. My new flash drives just showed up in a box. I'm going to go in and basically pop a drive, take it out of the chassis. Now, those are flash cache layers, so I'm just going to wait until the drive light inside says it's recognized the drive missing. I'm going to pop the new drive back in. It'll discover it, begin caching to it. All right? And I'm going to do that for each of the drives. So I'm going to take my 300 gig drives out, and I'm going to replace them with 600 gig drives, which are sitting in little plastic bags on the chair outside the door as well. All right? At this point, I should have a configuration that's twice as fast and has twice as much flash capacity on it. And then I've already done the racking. So in the server room, I have another chassis. Now I'm only going to put one in today, but it's already racked. It's sitting in there. I've got the cables. Out on the chairs are a pair of SAS cables. I'm going to go in and basically connect my server head to the new storage the storage tray, and power up the storage. And what we should see is the storage appear in the UI, which will be sitting on the chair over there. And then I'll simply have an activate button to bring that storage online. All right? And so through the process of these next couple of steps, I'm basically going to add more CPU, add more flash, and add more capacity. And the only thing I really need is the screwdriver to make sure that I haven't tightened the other screws too tight, and a couple of parts that are sitting out on the chair there. All right? There's plenty more we could dig into, but what I'm going to do, like I said, is set my laptop up over here on a chair so that you can watch that performance monitor go, and I can turn this screen back over to the presenters. All right? And you'll see me pop back and forth to the...
Michael, the whole point is that all of this is non-disruptive to the workload.
Correct.
This is a running workload within all of this.
Yes. So I will have a monitor up, and I'll be running something like iometer to the array, producing that workload, and so that you'll be able to see that essentially things will keep running, and the graph will basically jump up in performance, and then we'll see the capacity added in the management UI. The one thing I want to point out, one last bit before I go, and this is going to be, so here's the TFD demo, and I want to show you just a couple of things here. This says it's a CS260G. All right, we see the model number right here on the management array, on the management interface. That's the model that's in there currently right now. And if we hover over these drives, they say they're 300 gig flash drives and they're online. You basically see I have a healthy system. My online controller on the right, my standby controller on the left. These things are going to switch back and forth as I do this little song and dance. When I come back, these should say 600, and this should become a 460G. All right? And I'm going to leave this window basically over there so that you don't see anything happen. You'll see things go red. You'll see things go back and forth, because what's going to happen is I'm going to go in there and do some administration, but it won't stop the services to the user. All right? And then we'll see that the extra tray appear at the bottom of the screen here. So I just kind of want to give you a little heads up on what's going to happen over the next probably 15, 20 minutes or so as I run back and forth to the server room. All right? We're not timing this, all right? But it won't be very long.
Well, you might not be timing it.
All right, with that, let me
Where is this?
exit this, and
I'll get it.
I will set up over here.
Yeah, there's an app for that.
All right?
I have a question that
Sure.
You can hand off while you're running off to do
Yeah.
your 15-minute update, not that we're counting.
Okay.
If you've got one blade or one controller upgraded and one not,
Right.
what are the concerns there? When do you, how long do you feel it's safe to run in an imbalanced 2-to-1 controller base like that?
Yeah, I could take that.
Yeah.
So
Okay.
that's not a configuration that we would support in the field, but the
Mhm.
system would be stable in such a configuration.
Okay.
So if it depends on the controller that is active. You have an active standby mode.
Mhm.
If the controller that is active is the higher end controller, then the performance would be higher.
Right.
That's basically the difference. You can
Okay.
actually, in such a system, fail over between the two controllers and see the performance move.
Okay.
So there's no feature set difference, it's literally just the hardware inside.
It's basically the number of CPU cores and the amount of memory. And the system adapts to the difference in memory.
You wouldn't want to run long-term because
Right.
you get, depending on which controller is active, you get different performance. So the intent is only to run that during an interim period where you upgrade, but there's no, like it's going to be unstable in 10 minutes or anything.
Okay. It's not going to beep up a storm and have my data center guys coming out to kill me.
No.
Okay.
Is that true to the entire line as well? So all the way from the CS210 all the way to the CS2460, it's the same?
Yeah, it's all running the same software. Yeah, the question across the product line, it's all the same software line, and the scale out that we talked about allows you to mix and match all those in the same cluster. So you can be running a 220, then decide you want to add a 460, and cluster those two together with scale out, and add a combination of disk shells to those all.
I noticed there's a difference between the 260 and the 420 where there's a high performance and extreme performance, and the difference is there.
So the difference is, what we call high performance is the 200 line, and then the 400 line is what's got the upgraded CPUs in memory.
Okay.
That was what you were seeing from Michael's demo, so that's what we call extreme.
So there's really only two models of controllers, right?
There's two classes of controller.
Right, but they're all compatible. I mean, as far as when an upgrade goes, right?
Yeah, so you can take any, with the exception, we've got a 210 that has a couple of limitations on where it can be upgraded, which is our just very lowest entry level. Everything else is fully upgradable across every combination, if that makes sense.
So your backplane is compatible, all of that, or whatever the chassis are.
Chassis are all the same and fully compatible. Right.
Cool.
I'm sure it's intuitive. The reason the CPU gives us nearly more than a doubling in performance is simply because we are bound by the amount of CPU you can throw at the serialization process rather than by the spindle process, right? So log structuring requires us to use compute, compression requires us to use compute, all of which aid the write IOPS. So that's where sort of our ability to, and frankly, if we had more cores, then you would see or the same number of spindles, you'd see the IOPS continue to scale up, right? So it's limited entirely by how fast we can convert random IO into sequential IO, and that's a compute limited task.
So is the software stored in the chassis or is it stored on the controllers?
Well, the image of where things are stored is out on the disks in a special partition that's out there.
Okay.
There's a small little bit of boot flash that's sitting there on the controller, but essentially everything is sitting on the disks.
Okay, so you upgrade a chassis, not a controller. Okay. So you could
Is
take,
that right?
that's what you said, right? It's spread across the disks.
The code lives on the array.
What you can do, in fact,
but it
is
runs on
move
the controllers.
move the entire drive set from one chassis to another, and with that it will carry its data and the code.
And you can do that between versions of the controller as well. So you can,
Between
That's
classes?
right.
yeah, between classes.
Sure.
So
we can replace the chassis too. That's,
I mean, I could see upgrade reasons, but theoretically you could even downgrade the
That's
data
right.
set. That's really good. Yeah,
Yeah.
that's, yeah, a few companies do that, and that's actually fairly handy to be able to do that, have that flexibility.
Although it always irks me to give up space on my disks for your firmware.
Oh, you're not losing anything you'd notice.
Not with these guys, but with the major players, it's, you know, here's the 3
Players.
disk array
Clarion?
that,
Yeah.
well, or
Or
NetApp.
Solera.
I think
There are limitations on that
Yeah, you
first
can't use
volume
these
that you
disks,
can't
yeah.
fully use.
And I think it's not space as much as the need to create a separate root volume, which has information.
Right,
system
yeah, and
information.
it's
You're
that
wasting a
they
ton
do
of
stupid
space.
layout.
Indeed, and it's exactly right. You're wasting a ton of space there to store a small amount of data, but it needs to be a separate
Right.
contained
Yeah.
volume. And that's what causes you to sort of do that in the NetApp system, or actually many of the.
Yeah, most of them, it's, you know,
Indeed.
yeah, you have to dedicate 3 disks to this stupidity. And since the smallest disk we sell is 300 gig, Yeah,
That's a
you're
best
giving up-
practice in NetApp too, is to
Yeah,
do that.
Yes.
with both the MC and NetApp, it's,
Mhm.
you know, I always found it terribly irksome. It's like, oh man, why don't you guys like spend $500? I spent 50 grand on this machine. Why don't you spend $500, put 2 SSDs in each controller, and give that back to me?
You have to go through, in order to, yeah, I mean, it doesn't matter, that's a NetApp, NetApp will explain why. You have to go through Waffle without that, and that has to be at the back end of the
Yeah,
RAID
it's,
subsystem, so they don't have much of a choice on that.
Yeah.
The one comment I do wanna make is of all the scaling modes that we've described, the non-disruptive software upgrade, there are some that can do it. The, adding shelves non-disruptively and making the capacity available, most storage vendors should be able to do that. I don't know of any vendor that non-disruptive to an application can either change cache ratios or more importantly, change controllers and change the performance profile of a running application. I don't know of any storage system that can accomplish. That was a fairly big, even as we were doing scale out, a fairly big learning for us was many environments where you need to just change performance profile and capacity is adequate. VDI is a good use case. Scale out is too heavy a hammer. It basically requires you to buy an entire additional chassis when all you're looking for is incremental performance because your workload needs more performance but not more capacity. And that was a major endeavor for us is how do you non-disruptively change the performance profile for running application.
And-
Sorry.
Oh, no, I'm sorry. When you have very different, in terms of performance, arrays in the same pool, I think you called it, does whatever the controller that's in charge of directing traffic take that into account, or is it just spread evenly across?
So this is in a scale-out cluster, and you know, just describe how the host side. So when you have in a scale-out cluster, your volume striped across multiple controllers, and essentially you have different IOPS capabilities. So the host is directing I/O directly to the controller and to the chassis or to the array, to the node that has your data, right? So
Okay.
if it's a volume spread across 5 nodes, it's going directly to the node that has your data. It's possible that the node that has one slice of data for that volume is completely underloaded, another one is completely overloaded. But we also, by and large, because we distribute based on the method by which we distribute data across nodes is automatically rebalanced. By and large, what you tend to see is that it's uniformly linked to the performance itself.
Okay.
But it's possible to get to that scenario, and in which case you just non-disruptively
so
move as
as you
need to.
create a new stripe, you put it on the least busy kind of.
What we do is we break up a volume into smaller chunks of
Right.
bits that are distributed across all in a random manner. And so at any point in time, there's equal number of slices distributed across the entire cluster.
Okay, but it's random.
Correct.
Fine. So
It's pseudo-random at a fine enough granularity that we do not expect hotspots.
Are you doing hashing for that?
There's a combination of hashing and some amount of explicit mapping as well.
So the other thing is that administrator has an ability to define logical, groups within the large pool. So it doesn't have to be all broken into one big pool.
Right.
So if you have a 400 class and you have VDI, you can keep a pool and say, I want to limit it and make sure it never stripes over to this 200 class over here. There's an ability to do that. You don't explicitly typically need to do that, but if you want to administratively, you've got the ability to.
right. And of course, politically, it ends up being, well, this department bought that with this grant money.
Yeah.